When secondary systems with a good potential leaving group attached undergo solvolysis reactions through the SN1 mechanism, a skeletal rearrangement is possible. We can see in this example a secondary bromide is going to be lost to form a carbocation, which then rearranges, with trapping then of the solvent to produce the rearranged product. Because we are at neutral pH and there are no good nucleophiles present, this reaction is likely to occur through an SN1 mechanism, particularly in a polar protic solvent such as methanol. Here we can see that the bromide leaving group breaks off to form a secondary carbocation, which has a strained four-membered ring next door. This four-membered ring can then rearrange with alkyl migration to generate a better tertiary carbocation, which is also less strained. This carbocation is also prochiral, and so when the nucleophilic solvent comes in, it can attack from the top or bottom to produce an enantiomeric mixture of products. The alkoxonium species is then deprotonated by solvent, and that produces the racemic mixture of ether products. Since this is an SN1 reaction, the first step will be rate determining, in which the leaving group is lost to form the unstable carbocation. And because this is an unstable carbocation being secondary, and it has a strained four-membered ring attached, this will undergo rearrangement to form a much more stable tertiary and less strained carbocation as shown. Because the carbocation is flat and unsymmetrical, it is said to be prochiral. Therefore, the solvent may attack from the front to the back to produce a racemic mixture. The alkoxonium species are then deprotonated in a fast step, and that gives us the ether products, 50% of the R and 50% of the S in this case, and therefore a racemic mixture. Secondary alkyl systems with good leaving groups attached are capable of undergoing SN1 reactions with skeletal rearrangement. The leaving group breaks off to form the carbocation in the rate determining step, and then the rearrangement occurs to give a more stable carbocation, which is then trapped to give the products.